Welcome to Lesson 2, Graph Cubic Functions by Hand. In this lesson, you're going to learn how to roughly sketch a graph of a cubic function by using the characteristics that you learned about in the last lesson, as well as finding the x and y intercepts to roughly sketch these graphs. Down below here, just a reminder, these are cubic functions. So notice the turning points. We have 1, 2 in the first one, 1, 2 in the second. That indicates that this has a degree of 3. Remember that if we take the degree minus 1, that tells us the number of turning points. The other thing I want you to notice is the direction, or I guess you could call it the slope of these cubic functions. Remember that if we took the ends, so we've got an end down here and an end up here, and we pulled those taut, this cubic function would look like a linear function going in the positive direction. So this is a positive cubic function. Whereas this one on the far right here, if we pulled these ends, so this one would go up and this one would go down, you can see then it would look like a linear function, only in a negative direction with a negative slope. So this is negative. And that's going to be important when we sketch our graphs. Okay, one other thing I want you to notice is that this function here has 1, 2, 3 x-intercepts. This one here only has 2. Typically, the degree of the function is going to tell us how many x-intercepts we have. So in this case, this is a cubic function, meaning that it has a degree of 3. So we should have 3 x-intercepts or 3 x's. Right now, this one looks like it only has 2, but in fact it has, and we'll explore that in the first example. Okay, looking at our first example, we have this cubic function. This doesn't look like the cubic functions of last lesson, but we know it's a cubic function because all we have to do is count how many x's we have. So here, this first x, it's all raised to the second power. So how many x's really is that? This is 2 x's in this first set of parentheses. Then if I look at the second set of parentheses, this x, this whole thing is only to the first power, so we only have 1x. So we do actually have a total of 3 x's, or 3 factors, or 3 x-intercepts. So if you remember from quadratics that the terms in the parentheses are actually our x-intercepts. So what I'm going to do is I'm going to first locate our x-intercepts here. And remember how we do this. We take each term in parentheses. So here we have x minus 3. And this, again, x minus 3 because we have 2 of those. And then this last one is x plus 5. And we are going to find our x-intercepts from here. So to do that, we set y equal to 0 for all of those. Remember that anywhere on the x-axis, y is always equal to 0. So we can find our x-intercepts by setting each of these factors equal to 0. And in this case, for this first one, if we set it equal to 0 and we solve for x, we would get x equal to positive 3. And in the second one, same thing, x equals positive 3. And in our third one, though, we would have to subtract 5, so x would be equal to negative 5. So those are our 3 x-intercepts. So what I'm going to do is I'm going to write those here in my t-table. So I have a 3, and I have another 3, and I'm writing these both just for now, and I have a negative 5 when y is 0. So if I plot these on my graph, I have a x-intercept here at 3. Oh, and then I have another one here at 3. Well, it's the same dot, so I don't need to plot a second point, obviously, because it's in the same place. And then I have one here at negative 5. So that is why sometimes it looks like there's only 2 factors or 2 x-intercepts, when in fact there are 3, just sometimes one of them may be listed twice. All right, let's go ahead and move on then. Let's do the other intercept. Let's look at our y-axis. Let's find our y-intercept. So remember that our y-intercept, if we're trying to find that, the value of x is going to be 0. So what I need to do then in order to find y is to plug in a 0 for the rest of my terms. So down here, what I'm going to do is plug in a 0 for these terms in place of x. So I'm going to have 0 minus 3 squared times 0 plus 5. So if I solve all this, I will know what my y-intercept is. So I'm going to simplify. 0 minus 3 is negative 3, and negative 3 squared is positive 9. 0 plus 5 is just 5. If I multiply all these together, I get 9 times 5 is 45, and 45 times 3 is, I believe, 145. But let's double check and make sure that we are correct. So 45 times 3 is, 135. Not quite correct. Very close, just not quite. All right, so my y-intercept is going to be 135. Obviously, there is no 135 on this graph, so this is going to be a rough sketch. I just know where this is going to be. It's going to be somewhere way up here. Okay, now let's think about this graph. My leading coefficient is a positive 3. So if I make a rough sketch of this graph, I know it's going to go from left to right up in the positive direction. I also know that my graph needs to have 2 turning points, like I've just drawn here, because it's a cubic function. So it needs to look roughly something like this. So I'm going to need to start down, like this arrow, and come up through this x-intercept point. But I know I need to come really high up here. So I don't know necessarily that this y-intercept is the turning point. It could go through it. And then I need to come back down and then come back up. Notice that I did not cross down. If I were to cross down, that would create an extra x-intercept, and we know that we only have these 2 x-intercepts. So when I got to this last point, I have to curve back up. And I want you to notice that this x-intercept was the 3. This is the one that I had 2 of right here. So let's go ahead and highlight that. So I had 2 of these. This is also a hint on how to graph. Anytime you have a factor that is even, that's squared, then you know that it will just touch the x-axis and then go back the way it was coming. It will not cross through it. But again, logically, the other way you know is because we can only have these 2 x-intercepts. And if I were to continue down like this, well, I would need to come back up. I would need to come back up through the x-axis in order to create this image. And that would then create an extra x-intercept, which I know that I do not have. Okay, so this is all about fitting the pieces of the puzzle together in order to graph your cubic function by hand. So if I were to graph this on an actual graphing calculator, it would be very close to this, with the exception of where the turning points are, because I just don't know where the turning points are since I have no way to calculate that doing a rough sketch like this by hand. All I know is my y-intercept is here, my x-intercept is here, x-intercept is here, and this is the approximate shape of the graph. All right, let's try one more, and then you will get to try some on your own. Okay, here's our second example. So right away, we can see we have 1 axis, so we know it's definitely a cubic function. And I'm going to go ahead and plot my x-intercepts. So this first one, remember that if we take x minus 1 and we set it equal to 0, my first x-intercept is going to be at positive 1. My next 2 x-intercepts are going to be the same because this is squared. So I'm going to have 2 of the same. So this time I'm just going to put 1 on my t-table. So if I set this equal to 0, then x would be equal to -3. So let's go ahead and plot those. So I've got a x-intercept here at 1, and I've got one here at -3. The only thing I have left to do is to put in a 0 for x in order to find my y-intercept. So let's go ahead and do that. So y is equal to a -0 minus 1 times 0 plus 3 squared. So I have to keep track of this negative in the front. 0 minus 1 is going to be a -1. 0 plus 3 is 3, and then 3 squared is 9. So I just need to multiply all this together. Oops, that's a y. Well, so this is like a -1. So what I have here is negative times -1. That would become +1. And +1 times 9 is going to give me +9. Okay, and now I'm going to plot my y-intercept of 9. All right, the next thing that I need to do then is I need to make a rough sketch of my graph. So if I look up here, I can see that there is a negative in front. So I know that if there's a negative, my graph has to slope down from left to right. But it also needs to have 2 turning points. So I need to have a turning point. There's 1, there's 2, and continue down. So it needs to look something like that. It has 2 turning points. Okay. So I can tell you how it starts, right? Because this is helping me with my end behavior. This end starts up and it comes down. Now what I don't know right now is, will it come all the way down and then back through? Well, think about what would happen if I did that. So if I came down here, so I'm just going to do a dash line so I can erase it if I need to. I would need to come back up through here, which would cause me to miss my y-intercept, and then I still would need to have another turning point, which means I would have to intercept the x-axis again, and that would not be correct. So I cannot pass through this first x-intercept. And the other way that I know, remember, if we have a factor or an x-intercept that's even, meaning it's to the 2nd power, to the 4th power, to the 6th power, we know we're just going to touch the x-intercept and then we're going to go back up. So this is definitely going to head back up. It's going to go through the y-intercept and then come back down through my second x-intercept. And now I have my 2 turning points, my x-intercepts and my y-intercept. And again, the y-intercept does not represent a maximum. It just represents a point that the graph goes through. Our next lesson, we're going to be graphing these using a graphing calculator, and we will actually determine the local minimums, the local maximums, as well as the end behavior and the turning points. But for now, a rough sketch is fine when you're graphing cubic functions by hand. Okay, so let's review. So you are now able to graph a cubic function by hand by finding the x and the y-intercepts. And you are also able to graph it by hand by understanding the characteristics of a cubic function and knowing how to draw it roughly if it's positive versus negative.